You've likely spent hours sitting at a desk, staring at a screen while a dozen browser tabs compete for your attention. You're trying to grind through a dense report, but you've hit a wall of mental fog that makes every sentence feel impossible to parse. Cultural advice usually frames this moment as a test of moral discipline. We assume that focus is the direct result of willpower, that if you can't concentrate, you simply aren't trying hard enough. But the brain is an organic system, not a digital processor. It is a biological organ that runs on glucose and oxygen, governed by the strict rules of developmental molecular biology, rather than the demands of your to-do list. Human physiology evolved for movement and environmental scanning, which creates a profound mismatch between our biological design and the modern workday. Expecting the brain to perform in a stationary, high-stimulation environment for 8 hours a day contradicts how our neural networks actually function. When focus slits, we are experiencing the physical friction of trying to operate a biological system outside of its evolutionary parameters. We attempt to compensate for this friction by multitasking. We answer emails during meetings and monitor Slack while writing strategy documents, believing we are maximizing our output. The brain is incapable of true parallel processing for cognitively demanding tasks. It relies instead on attention switching, the process of rapidly disconnecting from one neural network and booting up another, over and over again. This chart illustrates the cost of that habit. Every switch depletes the brain's glucose reserves and increases the energy required to re-engage with a task. As the switching frequency rises, energy levels drop, and the error rate begins to climb. Frequent task switching rapidly exhausts energy reserves and degrades work quality across the board, making the attempt at multitasking fundamentally counterproductive. Despite this exhaustion, many work cultures demand that we ignore the fatigue and keep pushing forward. This forced labor triggers the release of cortisol, a stress hormone designed for short-term survival rather than sustained, complex problem-solving. As shown here, chronic high levels of cortisol physically impair the brain's ability to process and retain new information. A brain saturated with stress hormones is biologically incapable of deep learning. To counter this, the brain requires movement. Exercise increases blood flow, which delivers the massive amounts of oxygen and nutrients needed for executive functions and decision-making. Recovery is just as critical. A study conducted at NASA found that in high-stakes environments, a carefully timed 26-minute nap could improve alertness and performance by roughly 34%. It requires fueling the system with oxygen and strategic rest, rather than relying on stress to power through. How we feed the brain information also matters. Staring at pages of text for hours ignores the biological rule that vision is our most dominant sense. The brain has evolved to process images and spatial patterns far more effectively than it processes written words or spoken instructions. Moving information from short-term to long-term memory requires using specific retrieval-based strategies that align with how the brain actually encodes data. The first strategy is active recall. Forcing the brain to retrieve information builds stronger neural connections. This is reinforced by spaced repetition. Reviewing information at increasing intervals, like day 1, 3, and 7, signals the brain to permanently store data. Learning is not about the total volume of hours spent. It is about the timing of the biological formatting. Peak focus is a physiological state. You achieve it by respecting your biology, rather than trying to override it with willpower. Preserve your cognitive energy by closing unnecessary tabs and ending the cycle of task switching. Focus on one stream of work to keep your glucose consumption efficient. Incorporate movement and recovery into your day. Use a 26-minute nap or a short walk to flush cortisol and maintain the oxygen levels your brain needs to function. As the NASA data suggests, these small adjustments in recovery can yield significant gains in alertness and mental performance when the stakes are highest. By aligning your work habits with your biology, you can sustain the high-performance mental state that remains out of reach for those trying to force their way through the fog.